In the late 1990s, if you walked into a computer store, the choices sounded simple. Intel inside, or maybe a cheaper AMD or Cyrix box if you were watching your budget. But hidden behind those big names was an almost invisible contender, a tiny company called Rise Technology, and its equally tiny x86 processor, the MP6. The MP6 never became a headline product. It didn't power brand-name desktops, it never topped performance charts, and most buyers never even knew it existed. Yet, for hardware history buffs, it has become one of those fascinating footnotes, a chip that tried to bend the rules of the PC world, then vanished almost without a trace. This is the story of how a small team of engineers set out to build a low-cost, low-power rival to Intel's mighty Pentium line. Why, for a brief moment, it looked like they might just carve out a niche, and how the brutal economics of the CPU business eventually closed in. It's a story told from what the public record and scattered recollections can support. And in a few places, what we don't know is just as revealing as what we do. To understand why Rise and the MP6 even existed, we have to go back to the mid-1990s. Intel's Pentium had become the default standard for PC performance. The company controlled most of the market, set the pace of innovation, and poured money into marketing. Those Intel Inside stickers were everywhere for a reason. But Intel wasn't alone. Thanks to earlier cross-licensing deals, other companies were legally allowed to make x86-compatible chips. AMD was the most serious challenger, transforming itself from a second-source supplier into a true competitor with parts like the K5 and, more convincingly, the K6. Cyrix pursued a different path, focusing on value chips that could drop into existing sockets, often delivering solid performance for office work at aggressive prices. Its designs frequently ended up in no-name or big-box retailer PCs. There were even smaller players. Next Gen, with its Nex 586, tried a clean-sheet x86-compatible design and was eventually acquired by AMD, feeding into later CPUs. IDT's Centaur team built very simple, low-cost cores under the Win chip brand, aiming at basic home and business machines. All of this added up to a crowded and volatile market. Margins at the low end were already thin. Performance expectations were rising every year. And yet, for ambitious engineers in Silicon Valley, there was still a sense that if you could design something leaner, cheaper, and more efficient, you might carve out a profitable slice of this growing PC pie. Rise Technology emerged from this environment as a classic late 90s Silicon Valley startup story. Founded by engineers with backgrounds in microprocessor and system design, the company set up shop in California with the kind of ambition only a young semiconductor outfit could have: to build its own x86 CPU from scratch. Unlike AMD, Rise didn't have a long history as a second-source supplier. It was not a household name in the industry. It was closer in spirit to Centaur or Next Gen, a small, focused design house trying to challenge giants through clever engineering. The plan was not to outmuscle Intel at the high end. Instead, Rise aimed squarely at the low-cost, low-power segment. The idea was simple in theory: design a compact x86 core that was good enough for everyday Windows tasks, inexpensive to manufacture, and efficient enough to live in small desktops, notebooks, and maybe even embedded systems. In practice, the details of Rise's early funding and internal decision-making are thinly documented. Publicly, the company presented itself as a fabless chip designer, relying on external manufacturers to handle production. Privately, it appears they were betting that PC makers hungry for every last dollar of savings would welcome another alternative to Intel's pricing power, as long as compatibility and basic performance were there. At the heart of Rise's strategy was its first and ultimately only major CPU line, the MP6. Architecturally, it was designed to be small and efficient, rather than a speed demon. The MP6 implemented the familiar x86 instruction set, including support for Intel's MMX multimedia extension, which was important at the time for video, audio, and simple 3D tasks. Internally, it used a relatively modest dual-issue pipeline. Under ideal conditions, it could dispatch 2 instructions per clock, but without the deep, complex execution machinery seen in Intel's high-end parts. The die size was kept deliberately compact. A smaller die means more chips per wafer at the factory, which cuts cost, and with a simpler design, yields tend to be better. Rise avoided elaborate features that added area and design time without directly helping its chosen market. The trade-off was clear. On integer workloads that fit the design's sweet spot, the MP6 could be surprisingly competitive at a given clock speed, especially in office and basic internet tasks. But in floating-point heavy applications, or cutting-edge games, its simpler execution units and narrower pipelines lagged behind the Pentium 2, AMD's, K62, and even some Cyrix designs. Exact microarchitectural details differ slightly depending on the source, and Ryze's own technical documentation was never as exhaustive as Intel's. Still, the broad picture is consistent. The MP6 was a lean dual-issue MMX-capable x86 core, optimized more for cost and power than for winning benchmark shootouts. To turn the MP6 from schematics into silicon, Ryze embraced the Fabless model. Instead of building its own multi-billion-dollar fabrication plant, it partnered with foundries, most notably Taiwan Semiconductor Manufacturing Company, or TSMC. By the late 1990s, TSMC was already emerging as a crucial player for companies that wanted to design chips but couldn't or wouldn't own factories. For Ryze, this relationship meant access to a reasonably modern process technology without the capital overhead that burdened Intel and, to a lesser extent, AMD. This connection to Taiwan didn't stop at manufacturing. Ryze also courted Taiwanese motherboard and system makers, the companies behind many of the low-cost PCs that showed up in local computer shops in emerging markets. The idea was that if Ryze could offer them a compatible CPU at a lower price point, they could build ultra-cheap systems for schools, small businesses, and price-sensitive home users. Marketing materials from the period positioned the MP6 not as a Pentium 2 killer, but as the heart of affordable PCs and thin clients. Machines that could run Windows, handle productivity software, and browse the web without needing high-end performance. Precise contract details and unit volumes from these partnerships are hard to pin down today, but scattered product listings and surviving boards confirm that a number of small OEMs did, in fact, ship systems built around the MP6. When the MP6 finally reached reviewers and system builders, the reception was mixed. On the one hand, the chip generally delivered what Ryze promised: acceptable performance for office tasks and web browsing, low power consumption, and a price that undercut Intel's mainstream offerings. On the other hand, the competitive bar had moved. AMD's K62 and later K63 offered strong integer performance and, with 3D No, a credible story for gaming. Cyrix continued to push its own low-cost parts, even as it struggled with heat and reputation. Intel, sensing the threat from below, became more aggressive with Celeron pricing. In public benchmarks from the era, MP6-based systems tended to land near the bottom of comparison charts. They were often slower than equivalently clocked AMD and Intel chips, especially in floating-point and 3D graphics tests. For some OEMs chasing the absolute lowest bill of materials, that might have been acceptable. But for many buyers, a few extra dollars for a better-known brand and snappier speed felt like a safer bet. Exact sales figures for the MP6 are not well documented, and different accounts disagree on how many units actually shipped. What is clear is that the window for a small x86 clone vendor was closing. With Intel willing to defend share through pricing, and AMD finding real traction, the space for a third or fourth player at the low end narrowed sharply. As the 1990s rolled into the early 2000s, the pressures on Ryze technology intensified. The dot-com bubble, shifts in PC demand, and relentless price competition all made life harder for niche CPU designers. Larger rivals could afford to cut prices, invest in new process nodes, and support entire ecosystems of chipsets and marketing. Ryze's standalone CPU business never broke into the mainstream. Over time, the company pivoted away from trying to be a visible retail CPU brand. Its technology, however, did not simply disappear. Portions of the MP6 architecture and associated intellectual property were licensed or sold on, most notably to firms interested in using the core as part of system-on-chip designs or integrated multimedia solutions. The exact details of those deals are murky. Public announcements from the time are brief, and insiders have provided only fragmentary accounts. What seems reasonably clear is that the MP6 lived on in modified form as part of other companies' products, far from the logos and stickers of consumer PCs. Meanwhile, Ryze as an independent CPU contender faded from view. It did not become the next AMD, nor even the next Cyrix. For most PC buyers, the name never appeared on a box. Among retro computing enthusiasts today, though, MP6-based boards and systems have become curiosities, rare examples of a parallel path the x86 world might have taken had the economics turned out differently. The story of the MP6 is not one of triumph. There is no surprise twist where the underdog wins the market. Instead, it's a more common outcome in the semiconductor world. Talented engineers build a credible product, the timing and margins work against them, and the company vanishes into the background noise of industry consolidation. Yet that very ordinariness is what makes the MP6 interesting. It illustrates how unforgiving the CPU business can be. Success requires not just clever architecture, but deep pockets for manufacturing, aggressive pricing, strong relationships with OEMs, and the marketing clout to make buyers trust an unfamiliar name. It also reminds us how many parallel experiments were happening just beneath the surface of the 1990s PC boom. For every Pentium or Athlon that made headlines, there were designs like the MP6, targeted, constrained, and in some ways ahead of their time in focusing on power and cost efficiency. For collectors and historians, tracking down these obscure boards and processors is a way of filling in the gaps, of understanding the full spectrum of ideas that shaped the machines we used. The Ryze MP6 may never have been the fastest or the most famous chip of its era, but it remains a small telling piece of the larger puzzle, how competition, ambition, and hard limits on money and time shaped the computers of the late 20th century.